For this one, my cat Sophie is joining us, and we are going to be talking about writing conversion factors. In the United States, again, like we said in the last video, the contents of many packages are listed in both US and metric units. And so our goal for this is to learn conversion factors for two new units that are going to be describing the same quantity. Sophie says that. So equalities use two different units to describe the same measured amount. And they're written for relationships between units of metric and the metric system in the US units, or between metric and US, it says the same thing, metric system and US. So basically it's so we can bounce back and forth. So an example of this is 1 meter equals 1,000 millimeters. 1 pound is the same as 16 ounces. Or if we're going to go between the two of them, 2.2 pounds is the equivalent of 1 kilogram. So this skill is going to be writing conversion factors from these equalities, or things that are equal. Okay. So any equality can be written as fractions called conversion factors. So the conversion factors for the equality of 60 minutes equals 1 hour would be, you put the numerator on the top and the denominator on the bottom. Now, this is a stupid way to remember it, but demons live below the ground, right? So denominator, demo, is going to be the one that's on the bottom. So the numerator is going to be the one on the top, denominator is going to be the one on the bottom. So you can write this as 60 minutes are in 1 hour. And that can also flip-flop and be the same. 1 hour is 60 minutes. It really just depends on what we're trying to calculate and which one we need to have on top to make the equations work. So a conversion factors for metric could be 1 meter equals 100 centimeters, because again, everything's in 10. So you'd write that again. The numerator is 100 centimeters per meter, and you can flip-flop that because it is the same, okay? The numbers in any equality between two metric units or between two US systems are obtained by definition and are therefore exact numbers. We talked about exact numbers way at the beginning of Unit 1. A definition are exact, and they're not used to determine significant figures. An equality between metric and US units contains one number that's obtained by measurement, and that does count towards the significant figure. So an example would be the equality of 1 inch equals 2.54 centimeters. This has been defined as an exact relationship. And so therefore, 2.54 is going to be an exact number. Here is, again, some common equalities. Equalities just meaning things that are equal. Okay, so this is a great table to have at your table so that we can do some of these calculations. So length in metric is the same as US. The metric to US conversion, again, is exact, right? Okay. We can write metric conversion factors, such as 1 meter equals 100 centimeters. And again, like I said before, we can write numerator on top and denominator on the bottom, but they can flip-flop, again, depending on what we need to, for the advanced calculations. And the metric to US system conversion factors, again, 1 kilogram equals 2.2 pounds. You can have that either on the top or the bottom. And again, this will make more sense about, well, Janet, you're saying top or bottom, tell me what it means. And it really just depends on what our end product is, where we want to place that conversion factor. Okay. So, using that table, you guys can go back and say, work the conversion factors for inequality for each of the following: liters to milliliters. Milli, remember, is 100, right? Meters to inches, meters to kilometers. Okay, so take a second to think about that. Okay, so here are the solutions for that. It would be that 1,000. 1 liter equals 1,000 milliliters. So I misspoke before. I was thinking centi. Okay, so we would write that either as 1,000 milliliters per 1 liter or 1 liter per 1,000 milliliters. 1 meter equals 3.94 inches. Again, can be written either way. 1 kilometer equals 1,000 meters, and that can be written either way as well. Okay. So let's work on a problem. So a conversion factor may be started within a problem that applies only to that problem, and it's written for that problem only. Okay. For instance, the car was traveling at 85 kilometers per hour. So you can say 85 kilometers equals 1 hour. You can write that as 85 kilometers over 1 hour, or 1 hour over 85 kilometers. Okay. Same thing with the vitamin C. This is just showing you the flexibility of how we can write the formula. Okay, so 1 tablet equals 500 milligrams, 500 milligrams per 1 tablet, or 1 tablet per 500 milligrams. So those are all the same thing. Okay, so when we use this for like dosing, okay, equalities stated within dosage problems for medication can also be written in conversion factors. For example, Keflex, otherwise known as cephalexin, is an antibiotic used for respiratory and ear infections, and it's available in 250 milligram capsules. So again, 1 capsule equals 250 milligrams, or 250 milligrams per 1 capsule, or 1 capsule is 250 milligrams. So the 250 milligrams is measured. It has 2 sig figs, and the 1 in 1 capsule is also going to be an exact number. All right, so going on percentages now, building on top of this. The percent factor gives the ratio of parts to the whole, and it uses the same unit in the numerator and denominator. And it uses the value of 100 and can be written as 2 factors. Okay, so a person might have 18% body fat by mass. This is the thickness of the skin fold at the abdomen that you can see here with the little pincher guys, and is used to determine the percentage of body fat. So we know that 18 kilograms of body fat equals 100 kilograms of body mass. That's a known factor. So we can write that again in different ways. Okay, so this is just showing you that you can take that 100 kilograms body mass, that equals 1 kilogram of body fat. Okay, or 1 kilogram of body fat equals 100 kilograms of body mass. So let's apply this. Write the, I guess I'm not blocking, equality and the corresponding conversion factors, and identify each number as exact or given significant figures in the following statement. Salmon contains 1.9% omega-3 fatty acids. Okay. So again, the statement is salmon contains 1.9% omega-3 fatty acids. So what would that give us? If we take and rewrite that equality and its corresponding conversion factors, then we identify each number as exact or given with its significant figures for the following statement. What we are going to get is that 100 grams of salmon is the equivalent of 1.9 grams of omega-3 fatty acids, okay, because it was 1.9%. And again, we can use that as 100 gram salmon. Okay, so then we write this as 100 gram salmon is the equivalent of 1.9 grams of omega-3 fatty acids, and that would be the same if we flip-flopped it and be 1.9 grams of omega fatty acids, omega-3, per 100 grams of salmon. So that's how you can pull it out of a sentence and then apply it, okay, because percentages are per 100. Okay. Last study check. Write the equality and conversion factors of each of the followings. Meters and centimeters, jewelry that contains 18% gold, and 1 gallon of gas is $3.40. Right now, in the middle of COVID, I just got gas last week for $1.24. Huh. All right, so take a second. You can pause me if you need to. All right. So meters and centimeters, again, they're a factor of 100. So 100 centimeters is 1 meter, same as 1 meter is 100 centimeters. Okay, moving on to 18% gold. 18% or 18 grams of gold of 100% jewelry, or 100 grams of jewelry. This would be 100 grams of jewelry over 18 grams of gold, or 18 grams of gold per 100 grams of jewelry. Again, when you divide that up, that ends up being 18%. Okay, so even though this looks kind of complex, pull back a little bit and just be like, oh, okay, percentages are, per 100. So if I, do 75% of the work, I still have 25% of the work left to do. So, I mean, we know this. So pull back and make it so that it's like, oh, okay, it's in factor of 100. We're good. Okay, and then 1 gallon of gas is $3.40, and you can write that either way. Okay, all right, see you next video.